So we've seen that a heliocentric model helps us understand a lot more about the world around us. But what evidence is there other than this theoretical idea that it makes things look pretty? Well, Galileo Galilei is the first person that we have on record who actually has evidence, observational evidence, that we do live in a heliocentric solar system. So Galileo Galilei is the first person we know of to actually use a telescope to look into the heavens. The telescope had been invented about 2 years previously. He had heard about it and gotten instructions on how to make his own. So he did build his own and then also improved upon its design a little bit, and then he began looking up into the heavens. And the things he saw were in support of the heliocentric model. One of the things he discovered was that Venus goes through a full cycle of phases. So just like we talked about with the moon, how the moon goes through new moon and crescent and gibbous in these different phases to full moon, and then back, he found that Venus actually does the exact same thing. Well, this is only possible if Venus is actually orbiting around the Sun, which is evidence for a heliocentric model. So to hopefully help you see that this only works in a model where Venus is orbiting the Sun, we're going to start with the geocentric view. In other words, this is the Earth-centered, and see what it looks like from an Earth-centered view. Okay, so notice we've got the Earth at the center, and both Venus and the Sun are orbiting around the Earth. But Venus is a planet, so it has its epicycle, so it will swing from one side of the Sun to the other side and back from our point of view here on the Earth. Alright, so as we are watching this, notice we start it here at point A. At point A, we see what phase? It's going to be new Venus. Notice the dark side is facing towards the Earth. Then, Venus is going to swing out away from that center line, and as it does, we're going to start seeing a little bit of the light side. So over here at point B, we're probably going to see some sort of crescent Venus. Then as it keeps going, notice that it's then going to line back up with the Sun. So what phase are we going to see for point C? Well, it's going to be new again. So we went new, crescent, to new. Alright, well, let's keep going over to point D. Well, as it cycles over to point D, again, we're going to be able to see a little bit of that light side. So it's probably going to be some kind of crescent. So we went from new back to crescent. In other words, if Venus were actually orbiting around the Earth and not orbiting around the Sun, we wouldn't see any more than just Venus. Now let's take a look at what happens in a heliocentric model where Venus is orbiting around the Sun. Okay, so notice here we have the Sun at the center and Venus clearly orbiting around the Sun. So we start out again with new Venus. All we see is the shadow side. Then as it moves along, we start to see more of the light side. We see crescent. Then out this way, we'll actually see half. Then over that way, we'll actually get gibbous. And when Venus is at superior conjunction, if you remember that term from earlier, when it's at superior conjunction, we'll actually have full Venus. Then as it starts to keep moving around, we'll go back to gibbous, then half, then crescent, and then at inferior conjunction, we get back to new. So, the fact that Galileo saw the full cycle of phases shows that Venus must orbit around the Sun. Now, his telescope was not that great, nothing compared to what we have today. In fact, if you have a good pair of binoculars, I'm not talking about the little cheapy ones that you might find in the kids section as little toys, but good, decent binoculars, you can actually go out and see the phases of Venus for yourself. Although be warned, it takes a while. A full cycle of phases is something around 19 months or so. Something else that Galileo discovered were 4 of the moons of Jupiter. Okay, so he looked at Jupiter and he saw 4 dots kind of in a line, which at the time he actually assumed were just stars. But as he kept looking at them, studying them from one night to the next, and from 1 week to the next week, he noticed that they actually moved back and forth from one side of Jupiter to the other, which, if they keep going back and forth, means that they were likely orbiting around Jupiter, which means they are not orbiting around the Earth. Okay? And this is a model of our solar system. Now, in the actual solar system, we have the sun and the planets. In this case, it's Jupiter and the moons, but it's the same idea. So he actually used this as, again, support for a heliocentric model. Now, this handwritten diagram is not from Galileo. This was actually done by some Jesuit priests later. The circle in the middle is Jupiter, and the stars on either side are actually the moons, but you can actually see how it is that the moons are going back and forth from one side to the other. Now, you are probably aware that things did not go so well for Galileo as he was preaching the heliocentric model. He was actually placed under house arrest until his death. So sometimes it's good in the case of Brahe, sometimes it's bad, as in the case of Galileo.